In the previous sub-exercise, we found which proportion of reinsurance A that allowed for the adjustment coefficient to attain its maximum and therefore allows for the ruin probability to be as small as possible. Now, what we did not consider previously when computing A is whether or not this expression for A even satisfies the constraints on A. Well, we did check one constraint because in fact we did check that A is smaller than xi over xir. However, we did not check whether A was greater than 0. So if we consider this expression, you can see that A is greater than 0 if this term here, which is a negative term, if this term is numerically smaller than this term we have here. And we can actually see that if psi r is sufficiently large, then the second term will be numerically small. However, if psi r is not sufficiently large, then there may be some cases when this expression for A actually becomes negative. So we have to require that when we choose A, then we either choose this value or 0 if it turns out that this value is in fact negative. So a more precise expression for A would actually be the max of this expression and 0. Okay, now let's try to read the exercise text and see where we are asked, what is A if xi is equal to xi r? Let us try to first understand what this means. What does it mean if xi is equal to xi r? Well, then we have that the reinsurance premium is loaded exactly as much as the insurance premium. Which means that we are considering some kind of market where reinsurance and insurance kind of cost the same, have the same cost. And what happens in this expression for A if psi is equal to xi r? So in the expression for A, we have that xi equal to xi r implies that A is then equal to the maximum of xi over xir, which is just 1, plus 0, because this term will then just evaluate to 0. So it will be the maximum of 1 and 0, and A will then just be equal to 1, which means that the entire claim is paid by the reinsurance company. So in the case where the reinsurance and insurance premium have the same cost, then if we want to minimize the ruin probability, then the way you do it is just you stop doing business completely. And in fact, if you do that, then everything kind of breaks down, because in that case, what you can then note is that the premium that we pay to the reinsurance company and the premium that the customers pay to us will be equal, and therefore the premium term will just be zero. And since the entire claim will then be covered by the reinsurance company, the claim term will also be equal to zero. And then the total capital at any time is just equal to the initial capital. So the best way to minimize risk in this case will just be to not do insurance business at all, which doesn't seem to be a very useful thing to think of, to consider. Another thing that one may notice is that when a is equal to 1, then the adjustment coefficient is in fact unbounded, because for a going towards 1, the adjustment coefficient, well, what does it become? At least in this term, you get infinity, right? And well, in this term you also get infinity. So I guess if no, you don't get infinity. Sorry, in this term you just get 1 over psi minus psi r. So for a tending towards 1, the adjustment coefficient becomes infinite. And also, if you consider the net profit condition, then you will have that the expected premiums will be 0, which cannot be greater than the expected claims, so the net profit condition also breaks down. Basically, the morality of this is, in the case of proportional reinsurance, if you have a setup where the reinsurance and the insurance cost the same, then you just minimize your risk by reinsuring everything, but then you won't earn any money either. So the question of minimizing risk, well, that discussion is not very useful here unless you start considering something with utility theory, because if you go in and you think about the balance between minimizing risk and maximizing utility, then maybe there will be some more discussion to it. So yeah, in proportional reinsurance, if you want to minimize the ruin probability and the reinsurance and the insurance premium cost the same, then you just minimize the ruin probability by reinsuring everything and not earning any money.